In data 8, we defined a statistic as a number computed from the sample. Now we will give it its more formal name, actually a more general name, which is random variable. And to try to give a mathematical definition, we'll start with an example and see exactly how it's related to the sample. So let's suppose we have a population of ages. We actually have a population, say, of people, but maybe we're interested in the ages. A terrific mental image is that of a cardboard box. And in the box, each person is represented by a ticket that shows the person's age. So maybe here's somebody who's 19, here's somebody who's 81, 32, etc. And suppose you are drawing a sample of size 2. And assume you're picking at random. At the moment, it doesn't matter whether you're picking with or without replacement. And supposing that the statistic we are going to look at is the tried and true, the sample mean. Let's see how that can be related to the sample in some mathematical way. So supposing the sample were, let's see, 21 and 23. That's what I got. Then the value of the sample mean would be 22. Let's try a few more. 21 and 21. All right, so we have a bunch of means. And what is going on is that for every sample S, your sample mean is a function that is taking S to a value of the sample mean. And that function we are going to denote as capital X, just for brevity, right? Instead of saying sample mean, we're going to say X. And the value that has been shown in this column is X evaluated at the sample S. And now you see it starts to look like math. But what you're doing is for every sample, you are computing some numerical feature. And so for different samples, you'll get different values. Not all samples give you different values. Some give you the same value. But what you are saying is that the random variable is a function on the samples. And its values are numbers. So when you see capital X, it is important to think of it as a function. Its argument is a sample, which in math would be called an element of the domain. And it returns a number. Now, in the end, you can combine functions. Like you have a function f and a function g, you can add them, you can subtract them, you can divide one by the other, provided you're careful about zeros. And so, for example, if you have a bunch of random variables, then you can define new random variables. For example, if you look at the, oh, what should we do? Why don't we take a single random variable, try to predict it by a constant, and look at the mean absolute deviation. This is a function of functions, and so it's itself a function. This is now a random variable too. So any numerical operation that you perform on your random variables will give you a new random variable. You can calculate very complicated things based on your sample. And the more complicated, the harder it is going to be to work with that random variable. So it is a good idea for us now to build up some tools that help us to work with random variables.